Hello everyone, welcome back to Physics Compass. In our previous videos, we completed the entire theory of Unit 2, Kinematics. We discussed all the important concepts, understood the formulas, learned how different quantities are related, and worked through several examples together. Now, it's time to move to most important part of learning physics, solving exercise question. From today onwards, we are going to start solving the exercise questions of this unit. These questions will help us apply all the concepts that we have learned so far and prepare us for examination. While solving each question, I won't just give you a final answer. Instead, I will explain the complete thought process, how to identify the given information, which concept or equation to use, and how to solve the problem step by step. This way, you will develop the confidence to solve similar questions on your own. Here's a small suggestion before we begin. Whenever a new question appears on the screen, pause the video, try solving it by yourself first, and then continue watching. Compare your solution with mine and understand any mistakes you may have made. This is one of the most effective ways to improve your problem solving skills. So let's start with question number one. In question number one, says a particle moves from point A to B along the path of the circle of radius 5 meter as shown in figure 2.1 means here we have figure a particle is moved from A to B on this way, the actual path. Now we have to find the distance moved by the particle and in B we have to find the displacement of this particle. So we know that distance is for the actual path it covered and about the displacement it only cares about initial point and final point. So try by yourself. Now solution of A here, what is the actual path means you have to consider this way. Okay, so what is the value of this one? So you know the circle has circumference of 2 pi r, but here it covers half of the circumference, means it gives a value of pi into r, which is right here, and the r radius of this circle is 5 meter. Put the value here, and you will get the answer of 16 meter here. Now, for the displacement, we have to just concern about point A and point B. So, what is the shortest distance between these two point, which is along the diameter? Now, you know the radius diameter is given by twice into radius, means 2 into 10 means 10 meter. And we have to mention because the displacement is the vector quantity, means what is the direction of it. So it goes from this to this point, means downward direction. Here I mentioned that. I hope you clear the concept of question number one. Now we go question number two. In question number two, says the radius of the earth is 6.4 into 10 to 6 meter. One revolution about its axis takes time for 24 hours, okay, which is about 8.6 into 10 to 4 seconds. Now, to calculate the average speed of the point on the equator relative to the center of the earth. Now, for that, the earth is like this and it is revolving like like this axis, okay, about this axis. Now the point like here, it covers the distance for the 24 hours, which is like this way. If you actually, first point is here, initial point, and after 24 hours, it may cover the distance along the circumference, and after 24 hours, it at the same point of the initial. So in the answer, in 24 hours, the point on the equator completes one revolution and travels a distance of 2 pi into Earth radius, means its circumference 2 pi into r. R is the radius of the Earth here. Now, they given us the radius of the Earth, put value here, and you will get the answer about 4 into 10 is to 7 meter. Now, but we need to find the average speed. The formula of the average speed is like distance moved upon taken time. So we have a distance here 4 into 10 to 7 upon. It takes time about this 24 hours. You have to convert into seconds. Now you will get the answer about 4.7 to 10 to 2 meter per second. Now move on question number 3. Says how far does a cyclist travel in the 11 minutes if his average speed is 22 kilometer per hour? Now speed is given 20 kilometer per hour, but we have to convert it in the unit of meter and second. So you have to just do multiply by with 1000, convert in meter, and which is in hour, means you have to multiply with 60 for minutes and 60 for seconds, and you get the result about 6.1 meter per second. Now we also convert minutes into seconds. So you have to just multiply by with 60. Okay, and you will get this 660 seconds. Now we have to find that what is the distance covered by. So the formula for average speed is this delta x upon delta t, and you will get the delta x about 4026 meter. So this is about question number 3. Now, question number 4 says a train is traveling at the speed of 25 meter per second along a straight track. A boy walks along the corridor in the carriage towards the rear of the train at the speed of 1 meter per second relative to the train. Okay. Now, what is speed relative to the earth? Okay, we have to find that the boy speed relative to the earth. Now, in the solution part, we know in the 1 second the train travels 50 meter forward, means this direction along the track. At the same time, the boy moves 1 meter towards the rear, means this is a train speed direction, you can say, or the boy direction is about like this. Okay. Now the train is at the speed of 25 meter per second, and the boy is about 1 meter per second. Now we have to find that the what is the speed of the boy now, so that he moved 24 meter along the track, means you have to just subtract because the direction of both is opposite, or you will get the 24 meter per second speed related to the earth. So that's I right here, and his speed related to the earth is thus 24 meter per second. Okay, this is the concept of relative speed. I hope you understand these 3 questions. Now we go on question number 5. In question number 5 says a speed of electron in the orbit about nucleus of hydrogen atom is about 2.2 10 to 6 meter per second. It takes 1.5 into 10 raised to minus 16 second for the electron to complete one orbit. So calculate the radius of the orbit. Okay, consider the situation like this is the radius, this is the orbit of the electron, and this is the positive charge here. We consider here the hydrogen atoms means the one proton is here, no neutron available in this. So the electron revolving like this way. Now we have to find the radius. What is the radius over here? Okay, so we have a speed of the electron and the time period. That means the time required for the one complete revolution. It's called a time period. Okay, and the velocity of that. Okay, so velocity is given by like this. You can say that it covered distance is about 2 pi r means it is going along the circumference, okay, means 2 pi r and upon t. T means time required for the for one complete revolution means t. So here we need radius. So the formula it will be like this, and we have a v over here. T means time 1.5 10 to minus 16 second, and we also know the value of pi, and we can easily get the value of radius. So here I write speed of electron is about this, and time for one orbit complete revolution is about this. This is the given data, and the distance covered in the one circular orbit is about circumference, or you can write like this, which equals the speed multiplied by time, which I given to you earlier. Okay, so v is equals to total distance means 2 pi r, and the taken time means like this. Okay, and you will get the answer like this in the meter. Okay, so this is a question number 5. Now we move question number 6. Average speed of airliner on a domestic flight is about 220 meters per second. Calculate the time taken to fly between two airports on path 700 kilometers along. So we need to find the how time taken by this flight. Okay, okay. The distance between two airports is 700 kilometer, and the speed of the flight is about 220 meters per second. So the speed is 220 meters per second. Now the distance is in kilometer. So we have to convert in the meter because we need the same quantity here. Okay. If you don't follow this route, you will get a wrong answer. Okay. So the distance upon time. Now we need to find the time. Okay. So subject this term and you will get the answer about 3182 seconds. But if you want to find in a minutes part, so you have to just divide by 60, okay, and you will get the answer about 53 minutes. In question number 7, two cars are traveling in the same direction on a long straight road. The one is front of an average speed of 25 meters per second relative to the earth. The others is at about 31 meter per second. Also, relative to the Earth, what is speed of second car relative to the first when it is overtaking? So, let's suppose here there's a one car which is going about 25 meter per second speed, and the other one is behind of this car, and its speed is 31 meter per second, and at general knowledge, you know, the speed of the second car is more than this car. So after some time, overtakes this car. Okay. So what is the answer over here? Here I write what is the given data. So the speed of the front car is the 25 meter per second. Now the second car speed is about 31 meter per second. After some time, it will overtake this car. Okay, they are going in the same direction. Okay, now this is about 31 meter per second and this is about 25 meter per second. So after some time, it will overcome this car A. Let's suppose we name it the car A and car B. So when the two objects are moved in the same direction, here I show you that their relative speed is the difference between their individual speeds. So what does mean? Means V relative. We have to find speed of B, okay, relative to the A. You can write like this, okay. What does it mean? What does it mean? Means the velocity of B car relative to the A. Or if you write like this, VAB, it means that the speed of car A relative to the car B. Means the formula will be like this. And in this case, the formula is like this, VB minus VA. Okay, VAB, the speed of A car relative to the B car. And here, the speed of B car relative to the car A. So put the values here. We know the velocity of B car means or speed it is 31 and the speed of car A is 25 meter per second. Okay, you got the answer 6 meter per second. It is a relative speed. Okay, so suppose there's a case over here. The car A is going like this and the car B is going opposite direction. So what is the speed of B related to the car A? So in this case, the formula is like this: VB plus VA. Okay, the same value you can found in the case of like this. This is car is going this direction and the car B is also going in this direction. They are approaching to each other. Okay, so keep in your mind this kind of cases you will face or in the exams. Okay, so this is about the question number 5 to 7. I hope you will get the clear idea and the explanation and the concept behind it. Now we move forward into question number 8. Says a sports car accelerates along the straight pace track from race to 70 kilometer per hour in just 6.3 seconds. Okay. So what is this average acceleration? Okay. We have a you can say velocity. Initial velocity is about zero. The final velocity is about 70 kilometer per hour, and it is changing this 0 to 70 in about just 6.3 seconds only. So we have to find that what is the average acceleration. Okay, the solution is will be like the velocity, final velocity you can say 70 kilometer per hour, but you need either these units meter per second. Okay, so you have to just multiply by 1000 to convert kilometer into meter, and for hour you have to just 60 into 60, say 164 minutes and 164 seconds, and you will get the answer about 19 meter per second, and the time is already given in the seconds. Okay, so it's remain as it is. Now the average acceleration means delta V means final velocity minus initial velocity, okay, upon taken time. What is the time difference here? So Vf is equal about 19 minus 0 upon 6.3, and we'll get the answer about 3 meter per second square. So do not forget to write the unit of acceleration. So the unit of velocity, or you can say speed, is about meter per second, but the unit of acceleration is meter per second square. So keep in your mind, and while you're doing the question, so keep practice of write the correct unit. Okay. Now in question number 9, a railway train traveling along the straight track takes 1.5 minutes to come to rest, okay, from the speed of 115 kilometer per hour. What is its average acceleration while braking? Now, in this case, train is already in moving, okay, already moving with 100 150 kilometer per hour, but it must be stopped in 1.5 minutes. So in this case, we have initial velocity is 150 kilometer per hour, and the final velocity is zero because we are braking in the time 1.5 minutes. So it is a differ from the question number 8. Okay, so while you reading the question, so read question carefully. Okay, now we go on solution. The velocity is 150 kilometer per hour, but we need to speed in meter per second. So you have to just multiply by with 1000 upon 3600 means 60 into 60. Okay, here I write direct multiplication over here. Now you'll get the answer about 31.9 meter per second. And the time also given in minutes, but we need in second. So multiply by 60, you will get the answer time in seconds. Now the average acceleration here, the main twist is Vf minus Vi upon delta t. Now Vf is zero, means the final speed after braking. Okay, the train is stopped. Now Vi means 31.9 above 90. You will get the answer in negative, and the answer is of acceleration means meter per second square. But here you will see that the answer in negative. What does it mean? The velocity is decreases with the time, means you can say some kind of de-acceleration over here. Okay, in the first case, you see the car is going from rest to take some time to get velocity above like this. Okay, but in this case, train case, the train is already moving position, but we need to we brake the train, and after some time the train will stop. Okay, so this is the question number 8 and question number 9, and this is the difference between question number 8 and 9 over here. It's like this. Okay, I hope you understand question number 8 and question number 9 and the concept behind question number 8 and 9. And with that, we have successfully solved the questions covered in the today's solution session. I hope the step-by-step explanation helped you understand the concepts and the approach to solving these problems. In the next video, we will continue with the remaining exercise questions of Unit 2, Kinematics. Until then, keep practicing, stay curious, and I will see you in the next video. Thank you for watching. Subscribe for more physics lectures.